Okay, I hook up this display. It displays distance that the ultrasonic sensors measure. Watch. I put an ultrasonic sense. I put something on the ultrasonic sensor. There's too much light. It says 12 centimeters. And then if I put something else, remember this chocolate box? I still have it. I put the other ultrasound sensor here, so it measures 14 centimeters, 19 centimeters. So if I go farther, it changes, I think. And if it's less than 5 centimeters, the light goes on. And if this one's less than 5 centimeters, the other light goes on. I don't know where the other light is. Oh, right here. It's disconnected. Okay, so that's the other light, and I don't know why it's not going on. But the light goes on if it's closer than 5 centimeters. And so on. So the display shows how many centimeters is the distance, okay? Now, in this ultrasonic and this ultrasonic, I put two ultrasonics, and it goes flips and flops, checking the distance between one and the other one, okay? 10 and 17, 10 and 17. See, the chocolate box is about 10 centimeters, and this other little thingy is about 17 centimeters. So you have negative, positive, potentiometer, negative again, positive, and then this pin goes to 11, and then over here, D4, D6, D6, and D7, all those go to pin 4, 3, and 2. It says, let me go up, liquid crystal LCD, and it has 13, 11, 10, 4, 3, 2. Those are the cables that go to it. RS is 13, enable is 11, D4 is 10, D5 is 4, D6 is 3, and D7 is pin 2. Okay, I'll send you the code. Okay, so the way it's connected is this. I wish I had more light, but okay. First of all, it's positive and negative, okay? Positive and negative are the first two. The green is negative, the red is positive. Then you have a yellow. A yellow is an input. And then this one is green too. So this one is negative 2. Okay, so watch. The input, the yellow one, goes to the center of a potentiometer. So you need a potentiometer that goes from negative and positive. This is the negative and the positive. This is the negative and the positive. Okay, and then the potentiometer is a 10K potentiometer, gives input to the LCD. Watch what happens if I move the potentiometer. If I move the potentiometer to the right, the signal is gone, you cannot see anything. So you have to calibrate the potentiometer so that you can see. So I move it back and forth, and appears or disappears. So you need a 10K potentiometer to see the numbers. Okay? Now the other pins are here. The other pins are called, they have letters. It's D4, D6, D5, is D4, D6, D7, whatever. They have numbers there. 0, 1, 2, 3, 4, 5, 6, 7. So they have the numbers there. D0, D1, D3, okay. So I use the pins on the computer here, on the Arduino. The pins I use 2, 3, 4, and something like that. I'm going to show you on the code. Okay, this is the code. Include liquid crystal H, which is the library for the liquid crystal, and then these are the pins that go for RS, enable, D4, D5, D6, and D7. These are the trig pin for the first sensor, an echo pin for first sensor, trig and echo pin of second sensor. Instead of buzzers, I put LEDs. because buzzers make too much noise. Voice setup. I set up the pin modes, output and input. This is the first sensor. I just put duration. I set a duration variable and distance for just two variables, and then digital write high, delay microseconds a little bit, and then low. Just turn it on, turn it off. The first sensor, and then it reads the distance, then prints this distance in the monitor, serial monitor, and then prints it in the LCD. All you have to do is LCD print and put the distance, which is the variable that I put here, and then of course I put centimeters so that it says centimeters, and wait a little. Then if distance is less than 10 centimeters, we can change that, and then LED goes on and off. Then the second sensor is the same exact thing, and that's it. It finishes with a loop. The loop is printing first sensor and second sensor and delay.